Chapter 10, the gas law chapter in our textbook. Doesn't it feel good to have the calculations back and be doing things like mole calculations and unit conversions again? It's just refreshing to have them back. Now, I want to walk through one of the problems related to some of the end of chapter questions and mastering chemistry type questions. And this one is calculate the molecular weight of an unknown material in the gas phase, okay? And you're going to end up using, of course, the ideal gas law to do that. This is in particular, this is problem 10.54 out of the textbook. And this is one of those where, after doing the basic gas law questions, it gets into somewhat more of the applied, what do we use the ideal gas law for? And one of the big ones is calculating molecular weights. And when students first encounter this type of problem, they calculate molecular weights. Okay, I'll use the periodic table and add up, all the atomic weights. But wait, I don't know what the stuff is, so how can I do this? And it's true, up until this point, we've, calculated molecular weights simply off the periodic table. And so this one is a little bit of a twist on that, but think about it carefully. A molecular weight is grams of our unknown per mole, grams over moles of the unknown. And so somewhere in this problem, we're going to have to get our hands on two different numbers. We're going to plug them in, divide them, and get our answer. Grams of unknown and moles of unknown. Now, one of the numbers, the grams of the unknown, is given to us right there in the text of the problem. So let's take a look at the text of the problem itself, read it over quickly, and away we go. Reading through the thing, they tell us that we have an unknown material, we put it in the gas phase. The mass of the material, grams of unknown, is, and there it was, 0.846, 0.846 grams. So we've got that one out of the way. What we need now is moles. And like I say, moles, we usually calculate them from grams using molecular weights. We don't have that with us this time. So we have to have an alternative way of calculating moles. And in chapter 10, yes, indeed, it's going to be our dear, dear friend, the ideal gas law. Piv Nert is going to come and save the day. If you look carefully at the rest of the information in the problem, sure enough, there's a pressure and a volume and a temperature mentioned. Moles in these types of questions is here. PV over RT. Okay? And so really, it's a gas law question, like so many of the others that we've already worked on. We're going to have to get a number for pressure, for volume, and temperature. Of course, we already have the gas constant. Yes, we're going to have the hassle of making sure all the units line up perfectly, but, we can do that. Plug in our numbers, we will have moles, then we will divide it into the number of grams, and we will have our molecular weight. So it is a relatively straightforward problem, as most of them in this chapter tend to be. So, examining the various numbers for a moment, pressure. We are told it is 752 torr. Sure enough, it's a very nice pressure unit, but it's not the one we need here in the gas law with the gas constant, which uses atmospheres. So we have the standard bit of converting to do. And the conversion factor, 760 torr, similar to millimeters mercury, is 1 atmosphere. And so we punch that out on our handy dandy little calculator, and we're going to get 0.989 atmospheres. Okay? Pretty straightforward there. We have the pressure down. Volume. They tell us in the problem we have 354 cubic centimeters. Cubic centimeters. Yes, indeed, our dear friend milliliters in that cubic centimeter form, but we're used to that. Heck, that's chapter 1 type stuff. We're experts there. And of course, that is 0.354 liters. Okay, not much work there to get that one into the unit required. Here, that's pretty good. Temperature. We're told that this is the sample of gas is in a boiling water bath at 100 degrees C. That's pretty easy to convert to Kelvin. Remember, always be in Kelvin when you're doing this sort of stuff. And sure enough, we have 373.15 Kelvin. So here we have all three of the components necessary to calculate the number of moles, here using PivNert, pressure, volume, temperature, all in the proper units. And so yes, indeed, we start plugging and chugging. 0.989 atmospheres times the volume, 0.354 liters, divided by, here it comes, the gas constant, 0.0821. Oh, what a load of units it has. Liters, atmospheres, per mole Kelvin, times 373.15 Kelvin. Oh, doesn't that look beautiful? And sure enough, you look at the units, make sure everything's lined up properly. We have liters canceling, kelvins canceling, atmospheres canceling. The only unit left that doesn't get crossed off here is moles. We're calculating moles. It's kind of convenient. It works out that way. And we do the magic calculator dance, and 0.0, there it is, 114 moles of whatever unknown material this is. So there it is. Grams, now we have the moles. Now we just simply put them together. We have, let's see, 0.846 grams of the unknown. We have 0.0114 moles of the unknown. One more magic little calculator dance, and out should pop 74. I think it comes out 73.99, but you know what the heck. 74 grams per mole. And there is a perfectly acceptable molecular weight. There is the molecular weight of our unknown material. Okay? And so remember, in chapter 10, many of the, especially the later problems, require molecular weight or moles of something. And if you don't know what it is, you're not going to be able to use the periodic table to get moles like we're so used to. But our dear friend, the ideal gas law, is another way of getting moles. And so it's no coincidence they hand us pressures, volumes, temperatures, and the components we need in order to carry out the calculation. So there it is, a molecular weight using PivNert. Go think about it, do some calculations. See you later.